Hi students, welcome back to another session of Applied Mathematics session. Today we are going to see some characters of matrices. Today we are going to see a new concept called transpose of a matrix. Transpose of a matrix. If A is a matrix, then transpose of matrix A is denoted by A transpose, or simply it will be written as A dash. So A transpose is denoted by A with the T superfix, okay, or it can be denoted by A dash. What we are going to do in transpose of a matrix? What we are going to do in the transpose of a matrix? That is, in A transpose, we change row elements to column elements. How we are writing transpose of a matrix? A transpose, correct? The symbol itself suggests us what we are going to do. So we write the elements which are placed horizontally to vertical. Is it clear? Suppose if A is a matrix of order 2 by 2 with elements 3 minus 5, 7 minus 8. It is a matrix of order 2 by 2, correct? Then what is A transpose? A transpose is nothing but changing rows into columns. We are going to write the row elements. What are the row elements? 3 and minus 5. They are going to be written in column wise. So it is written as 3 minus 5. And second row, 7 and minus 8. It is going to be converted to column. So it is written as 7 minus 8. So 2 by 2. So this process of changing row elements to column elements is called as transpose of a matrix. Transpose of a matrix. Suppose A is a matrix of order 2 by 3. 2 rows and 3 columns. 5 minus 6 minus 7, 7, 5 minus 4. Now how to find A transpose? Tell me. A transpose is nothing but changing row elements to column elements. Which is the first row? 5 minus 6 minus 7 is going to be your first row. That row elements are going to be transferred to column elements. So when you change this one to column element, it is going to be in first column. It is 5 minus 6, 7. Interchanging row to column. First row is changed to first column. Second row. What is second row? 7 minus 5 minus 4. Now it is going to be written that second row element are going to be written in the second column. It is 7, 5 minus 4. So this is A transpose. Finding transpose of a matrix plays a very vital role in the next concept what we are going to study. Okay, finding the transpose of a matrix is very, very important. Is it clear? Now what are the properties of transpose of a matrix? Properties of transpose of a matrix. The first property is A transpose will be equal to transpose of a transpose. Okay, we are finding A transpose first. After finding A transpose, again we are going to transpose it. In such case, what you are going to get? We will be getting A itself. We will be getting A itself. Second one, A plus B whole transpose. A plus B whole transpose. That is finding the transpose for the sum of two matrices. Finding the transpose of sum of two matrices will be equal to, first to find the transpose of both the matrices A transpose and B transpose, then find the sum. So, A plus B whole transpose is equal to A transpose plus B transpose. Third one, A minus B whole transpose. A minus B whole transpose. It will be equal to A transpose minus B transpose. This is a very important property. What is the transpose of the product? AB whole transpose. AB whole transpose is not equal to A transpose B transpose. It is not equal, okay, but the product, the transpose of the product will be equal to product of their transposes taken in reverse order, that is B transpose A transpose. Is it clear? Matrix multiplication is not commutative, so we are not supposed to change the order of the multiplication, okay. AB whole transpose will be equal to B transpose A transpose. So these are the properties what we are supposed to learn about transpose of the matrices, okay. And very important concept is, if A is a matrix of order m by n, okay, A is a matrix of order m by n, that is, it is going to contain m rows and n columns. Then what about the order of A transpose? A transpose will have the order n by m, because we are going to change row to column, okay. So A is a matrix of order m by n means A transpose will have the order n by m. So this is a very important note we are going to make. Order of matrix A is m by n, then order of A transpose is changed n by m, okay. So these are the properties of transpose of a matrix. With this introduction, let us start solving problems based on transpose of a matrix. Now consider this question. If A is a matrix 2 minus 3 is 0, minus 1 4 5, then find 3A whole transpose. A matrix is given to us. A matrix is 2 minus 3 0, minus 1 4 5, okay. We are supposed to find 3A transpose. 3A transpose. So let us calculate what is 3A is. 3A is equal to, we multiply 3 scalar to the matrix, 2 minus 3 0, minus 1 4 5. So when you multiply, what you will get? How to multiply? Because it is the scalar multiplication, we have to multiply the scalar to all the elements. not to a particular element. We have to multiply 3 to all the elements. So 3 2s are 6, 3 into minus 3 minus 9, 3 into 0 0, 3 into minus 1 minus 3, 3 into 4 12, 3 into 5 15. So this is your 3a. But the question is not to find 3a. The question is about finding 3a whole transpose. 3a whole transpose. So how to find transpose for this matrix 3a? We have to change the row elements to column elements. It is a 2 by 3 matrix. We are going to change to transpose. So how to find? The first row will be converted to first column. So 6 minus 9 0 is written in first column. 6 minus 9 0. The second row minus 3 12 15 will be rewritten as second column element. That is minus 3 12 15. It is 3 by 2. Okay, very simple. So how to find a 3a transpose? A matrix is given. First find 3a. How to find 3a? Multiply 3 to all the elements of matrix A. So by which we are getting 3a. To find 3a transpose, we have to write the row element to column element. Transpose, T if you write, very simple to remember. Row element will be rewritten as column element. Horizontal way written element will be rewritten in the vertical way. Is it clear? So let us solve another problem in this concept. Now consider this question. If A is equal to 2 minus 1 5 4 0 3 and B is equal to minus 2 3 1 minus 1 2 minus 3, find A transpose plus B transpose. A matrix is given. A is equal to 2 minus 1 5 4 0 3 and B matrix is also given minus 2 3 1 minus 1 2 minus 3. We are supposed to find A dash plus B dash, that is A transpose plus B transpose. First we try to find out what is A transpose is. A transpose. How to find A transpose? Transpose is nothing but changing row elements to column elements. So first row elements will be written as first column element. So 2 minus 1 5. So first row is written as first column. Next, second row. What is second row? 4 0 3. 4 0 3 is now written as second column. 4 0 3. Now what is the order of this matrix? It is going to contain 3 rows and 2 columns. So it is 3 by 2. Now I am going to calculate what is B transpose is. B transpose is equal to, write first row as first column, minus 2 3 1. Now second row will be rewritten as second column, minus 1 2 minus 3. Now we are going to find A transpose plus B transpose. A transpose plus B transpose. Before adding, we have to check the order. Okay, this is a matrix of order 3 by 2. B transpose is also a matrix of order 3 by 2. So both the matrices are going to be of same order. A transpose and B transpose are going to be of same order. So we can add it. A transpose plus B transpose. So how to find out? 2, 4, minus 1, 0, 5, 3 added with minus 2, minus 1, 3, 2, 1, minus 3. Now both the matrices are going to be of same order, so we can add it. Now tell me how to add the two matrices. When the two matrices are of same order, the corresponding elements will be added. We are going to add the corresponding elements. What about the corresponding elements? First element of the first row will be added to first row, first column element of the second matrix. So we are going to add. So 2 added with minus 2. So 2 minus 2. Second element will be added with the second element. So second element in the first matrix is 4. Added with the first row, second column element minus 1. So it is 4 minus 1. Because 4 plus of minus 1 it is. 4 plus of minus 1 is nothing but 4 minus 1. Next, minus 1 plus 3. Second row, second column element of the first matrix added with second row, second column element of the second matrix. So it is 0 plus 2. Now, third row, first column element of the first matrix added with third row, first column element of the second matrix. So it is 5 plus 1. Next one is 3 plus of minus 3. So 3 minus 3. 3 plus of minus 3. So plus into minus is minus. So 3 minus 3 it is. So simplify this expression. 2 minus 2. 2 minus 2 is going to be equal to 0. 4 minus 1. 4 minus 1 is 3. Minus 1 plus 3. They are of different sign. So we have to subtract. So 1 is subtracted from 3. So it is 2. So it is plus 2. 0 plus 2, 2 again. 5 plus 1, 6. 3 minus 3, 0. So this is the answer. So this is the answer for A transpose plus B transpose. So very simple. So how to find A transpose plus B transpose? First we have to find the transpose of matrix A. Then you find transpose of matrix B. After finding the transpose of the two matrices, we are going to add them. Simple addition. Okay. The matrices can be added only when they are of same order. That condition alone we have to check it. Now see this problem. A is equal to 5 minus 1, 6, 7. B is equal to 2, 1, 3, 4. We are going to verify 4 subdivision. The first one is A transpose, whole transpose is A itself. Second one, 3A whole transpose is equal to 3 into A transpose. Then A minus B whole transpose is equal to A transpose minus B transpose. Last one, AB whole transpose is equal to BA whole transpose. Sorry, B transpose, A transpose. So first we try to solve the first one. A is equal to 5 minus 1, 6, 7. We are going to verify A transpose, whole transpose is equal to A itself. So we start. What is A transpose? A transpose is transpose of the first matrix, A matrix. That is A matrix, the row element 5 minus 1 will be written as vertical. Column element 5 minus 1. Next one, second row 6, 7 is written as 6, 7. So this is your A transpose. Now I am going to find out A transpose, whole transpose. A transpose, whole transpose. This is nothing but A transpose already we found out 5, 6, minus 1, 7. Now we are going to find the transpose of the transpose. So we are going to transpose this matrix. So here the row element will be changed to column element again. So 5, 6 is rewritten as 5, 6 as the column element. Minus 1, 7, the row element. Second row will be rewritten as second column. So it is minus 1, 7. We can very well see that we are getting back our first matrix itself. So by which we conclude A transpose old transpose is equal to A. Is it clear? Very simple proof. Next we are going to see second proof. Here we prove first one. Second one it is going to be 3A old dash is equal to, that is 3A old transpose is equal to 3 into A transpose. Is it clear? So let us study in detail. It is 3A old transpose. Matrix 3A is transposed. On the right hand side, we are going to find A transpose and then we multiply it by 3. Okay. So we start proving that. First we try to find 3A, which is nothing but 3 into A matrix. What is your A matrix? 5, minus 1, 6, 7. Is it clear? So it is equal to 3 into 5, 15, 3 into minus 1, minus 3, 3 into 6, 18, 3 into 7, 21. So we multiplied 3 to all the elements of the matrix A. Now I am going to find out what is 3A transpose. I found out 3A matrix. I am going to find the transpose. So what is the process of finding transpose of a matrix? Change row element to column element. So you will get 15 minus 3, 18, 21. So this is your matrix 3A old transpose. This is your left hand side. Now we have to find right hand side. Now A transpose. A transpose is nothing but writing A matrix transpose. So it is going to be, already we found out. Is it clear? We are changing it. Write the row element to column element. So it is 5 minus 1, 6, 7. 3A transpose. 3 into A transpose it is. So 3 multiplied with 5, 6, minus 1, 7. So multiply. On multiplication, what you are going to get? 3 into 5, 15. 3 into 6, 18. 3 into minus 1, minus 3. 3 into 7, 21. Now you can very well see that 3A transpose. 3A transpose is 15, 18, minus 3, 21. Correct? And here also what you are going to get? 15, 18, minus 3, minus 21. So what we conclude? If you take this as third equation, if you take this as fourth equation, we get 3 equal to 4. Correct? So by which we rewrite this statement as 3A old transpose equal to 3 into A transpose. Now we will prove the third one. Third one, it suggests that A minus B old dash. Old dash is nothing but transpose. Is nothing but A transpose minus B transpose. So what we are supposed to find out? A minus B old transpose. A minus B old transpose is nothing but we have to subtract the two matrices. A and B we have to subtract. After subtraction, we have to find the transpose, that is A minus B transpose. Right hand side, we have to find A transpose, we have to find B transpose, then we have to subtract B transpose from A transpose. Okay, so we start. First, we try to find out A minus B. What is A minus B? 5 minus 1, 6, 7 minus B matrix 2, 1, 3, 4. So, we have to add the first matrix with negative matrix of the second matrix. 5 minus 1, 6, 7 plus of, we multiply this minus sign inside. So, it is minus 2 minus 1 minus 3 minus 4. So, I do subtract, I add, okay, I add directly. It is 5 minus 2. First element added with the first element. So, it is 5 plus minus 2. It is going to be equal to 3. Next, minus 1 added with minus 1. Both elements are going to have same sign. So, we add and put the same sign. So, it is going to be minus 2. Next, 6 plus of minus 3. 6 added with minus 3. Different sign. So, we have to subtract, which is nothing but again 3. 7 plus minus 4. 7 minus 4. 7 minus 4 is nothing but 3. Now, I am going to find A minus B whole transpose. After finding A minus B, I am going to do the transpose. So, here the first row will be rewritten as first column. So, it is 3 minus 2. Second row will be rewritten as second column. So, this is the process of finding transpose. So, I got A minus B whole transpose. Okay. Let us mark this as fifth equation. Is it clear? Now, right hand side process we are going to start. In right hand side, what we are going to calculate first? A transpose. How to find A transpose? In A matrix, change row element to column element. So, 5 minus 1 row element converted to 5 minus 1 as column element. Next one, 6, 7. 6, 7. So, this is your A transpose. We are going to find B transpose. How to find B transpose? B transpose is equal to first row 2, 1 will be rewritten as first column 2, 1. Second row 3, 4 will be rewritten as second column 3, 4. So, we calculated A transpose and B transpose. Now, A transpose minus B transpose I am going to calculate. So, this is 5, 6 minus 1, 7 minus of 2, 3, 1, 4. So, the first matrix 5, 6 minus 1, 7 is added with negative matrix of the second matrix, that is nothing but minus 2, minus 3, minus 1, minus 4. So, we are going to add now 5 plus of minus 2, that is nothing but 5 minus 2. 5 minus 2 is nothing but 3. Then 6 plus of minus 3, that is 6 minus 3, it is going to be equal to 3 again. Minus 1 plus minus 1 added, same symbol, so minus 2. 7 plus of minus 4, it is going to be 3 again. So, we found out A transpose minus B transpose. I take this as sixth equation. Now, compare fifth and sixth. Are they equal or not? Obviously, they are equal. So, what is our conclusion now? Our conclusion is A minus B whole transpose is equal to A transpose minus B transpose. Okay. So, how we proved this one? First we are finding out A minus B. After finding A minus B, we are transposing that A minus B matrix. We take this as that as fifth equation. Then for the RHS, we take A transpose first, then B transpose, then we subtract B transpose from A transpose, that is A transpose minus B transpose, and we prove that both are equal. Okay. Now we shall prove the fourth subdivision. Now we will prove that AB whole transpose, AB whole transpose is equal to B transpose multiplied with A transpose. Okay. So this is the fourth subdivision. First we start finding the value for AB. A into B. A matrix is 5 minus 1, 6, 7. B matrix is 2, 1, 3, 4. Both are of order 2 by 2. So A is a matrix of order 2 by 2. B is also a matrix of order 2 by 2. So the condition for performing matrix multiplication satisfied. So the resultant matrix also 2 by 2. So no problem. So how to multiply? As usual. Okay. We have to multiply first row with the first column first. Okay. In first row we are having 2 elements. First column we have 2 elements. So we multiply first element with the first element plus second element with the second element. So we multiply 5 into 2, 10, minus 1 into 3, minus 3. So I multiplied first row element with the first column element. Now I move on to first row multiplying with second column. First row multiplied with the second column. So 5 multiplied with 1. So 5 ones are 5. Second element multiplied with the second element. Minus 1 is multiplied with the 4. So it is going to be minus 4. Then, so first row is multiplied with available columns. We are having only 2 columns on the second matrix. So we multiplied with the first column as well as second column over. Next we move on to second row. Now second row is going to be multiplied with first column. So first element is multiplied with the first element. 6 2s are 12. Second element is multiplied with the second element. 7 3s are 21 plus 21. We move on to multiplying second row with the second column. So 6 is multiplied with the 1, 6. 7 is multiplied with the 4. 7 4s are 28. Now we simplify this expression. 10 minus 3 is 7. 5 minus 4, 1. 12 plus 21, 33. 6 plus 28, 34. Now I calculate AB whole transpose. AB I found out already. I am going to transpose it. How to find the transpose of a matrix? Convert row element to column element. So first row is written as first column now. Convert row to column. So horizontal element will be written as vertical element. Second row 33, 34. So this we will take it as first equation. Now we are going to calculate the RHS. For RHS, what we are supposed to find out? We are supposed to find out what is B transpose is. B transpose. So B matrix should be transposed. So it is 2, 1, 3, 4. In B matrix, the row element should be converted to column element. Row element should be converted to column elements. Okay. Next we are going to find A transpose. How to find A transpose? 5 minus 1 are the row elements, which will be rewritten as column element. So it is going to be 5 minus 1. Second row 6, 7 will be rewritten as second column. So 6, 7. So this also of 2 by 2 order, this also of order 2 by 2. So we can multiply both of them. So we start multiplying B transpose with A transpose. 2, 3, 1, 4. Multiplied with 5, 6, minus 1, 7. How to multiply? We are going to multiply by row with the column. Okay. First row element will be multiplied with the first column element. Here we are having 2 element, here also we are having 2 element. So we start multiplying. First element multiplied with the first element. 2 5s are 10. Second element is multiplied with the second element. 3 into minus 1. It is minus 3. 2 into 6. 12. Second row multiplied with second column. 3 7s are 21. Then 1 into 5, 5. 4 into minus 1, minus 4. 1 into 6, 6. 4 7s are 28. 10 minus 3, 7. 12 plus 21, 33. 5 minus 4, 1. 6 plus 28, 34. And we name this as second equation. We can very well see that first and second equation values are same. So what we conclude? We conclude AB whole transpose is equal to B transpose A transpose. So here in the third subdivision we subtract and find the transpose and we prove it is A transpose minus B transpose. But in the fourth one it is AB whole transpose is equal to B transpose into A transpose. Is it clear? That is very, very important. That is, transpose of the product of two matrices is equal to product of the transposes taken in reverse order. Product of the transposes taken in reverse order. If it is AB, on the right hand side we will be having only BA. Okay, it will be reversed. We move on to next question. You can solve this one as homework. Okay, A transpose is given by which we can find A comfortably. How to find A from A transpose? How to find A from A transpose? Yes, exactly. If you want to find A from A transpose, we have to transpose A transpose because A transpose, whole transpose is nothing but your A. So find the transpose of this matrix by which you can calculate A, and you can take this problem as homework. In this problem, A transpose is given directly. A transpose is given directly. B is given to us. Okay, by which we can calculate B transpose. From the two values, we are supposed to calculate A transpose minus B transpose. We are supposed to calculate A transpose minus B transpose. Okay. Now read this question. Find the integral value of x if x4 minus 1 again multiplied with a 3 by 3 matrix 2 1 minus 1 1 0 0 2 2 4 multiplied with transpose of x4 minus 1. The matrix what we are having here is transposed here. So here we are having transpose. So we have to be very careful. So we rewrite this one after applying transpose. So this equation will be rewritten as x4 minus 1 multiplied with 2 1 minus 1 1 0 0 2 2 4 and x4 minus 1 whole dash is equal to 0. Okay. So we rewrite this one, this third matrix. Okay, we have to rewrite. Why we have to rewrite? It is going to be transpose. So when you rewrite, this expression will be changed to x 4 minus 1 multiplied with 2 1 minus 1 1 0 0 2 2 4. Okay, here only we are having transpose, so this is rewritten as x 4 minus 1. That's it. We are going to solve for x. We are going to solve for x. First we will check whether the matrix multiplication is possible or not. First matrix is of order 1 by 3. Second matrix is of order 3 by 3. So we can multiply both the matrices. On multiplication, we get a resultant matrix of order 1 by 3. So when you multiply first matrix with the second matrix, you are going to get again a row matrix. It is going to be simply a row matrix. Okay. Now it is going to be multiplied with a column matrix, which is going to have 3 rows and 1 column. So again, matrix multiplication is possible. The resultant matrix will be of order 1 by 1. We start multiplying. How to multiply? First row is multiplied with first column. Here we are having 3 elements. Here also we are having 3 elements. So we have to multiply. First element multiplied with the first element. So x into 2, it is going to be 2x. Second element multiplied with the second element. 4 ones are 4. So it is plus 4. Written together. 4 multiplied with 1, 4. Then third element is multiplied with the third element. So minus 1 is multiplied with 2. So you are going to get minus 2. So we got the first row, first column element. We move on to the next element. The same row is going to multiply with the second column. So x into 1. First element is multiplied with the first element. So x into 1 is x itself. 4 into 0. Second element is 4. Here second element is 0. So 4 is multiplied with the 0. It is going to be 0. Next. Third element is multiplied with the third element. So minus 1 is multiplied with the 2. It is going to be minus 2. Next. First row is going to multiply with the third column. So x is multiplied with the minus 1, minus x. 4 is going to be multiplied with the 0, it is going to be 0. Minus 1 is going to multiply with the 4, it is going to be minus 4. And it is going to multiply with x 4 minus 1, which is equal to 0. We simplify this one further. 2x plus 4 minus 2. We simplify. Plus 4 minus 2 is going to be plus 2. This is x plus 0 minus 2. So 0 has no value. So it is going to be x minus 2. The last one minus x minus 4. So it is going to be a matrix of order 1 by 3, which is going to be multiplied with x 4 minus 1 equal to 0. So this is going to be of order 1 by 3 multiplied with 3 by 1. So the resultant matrix will be of order 1 by 1. So it is going to have only one element. Okay. So we have to be very careful while multiply. So first element is multiplied with the first element. So 2x plus 2 multiplied with x plus second element is multiplied with the second element. So x minus 2 multiplied with the 4. Next. Third element is multiplied with the third element. So minus x minus 4 is multiplied with the minus 1. Right answer is going to be a null matrix rewritten as a matrix format, which is going to have element 0. Now try to simplify this further. 2x into x, 2x square, 2 into x is 2x. 4 is multiplied with x, 4x. 4 into minus 2, minus 8. Minus 1 into minus x. So it changes to plus x. Minus 1 into minus 4 plus 4 is equal to 0. So it is going to have only one x square term. It is nothing but 2x square. X term, we are going to have 3 terms, 2x, 4x and x. All of them are going to have plus symbol. So we add 2x plus 4x is 6x, 6x plus x is 7x. Finally, minus 8 plus 4 constant. Minus 8 plus 4 is going to be minus 4, which is equal to 0. So these two matrices are equal matrix. So corresponding element will be equal. So we equate the elements now. So it is rewritten as 2x square plus 7x minus 4 equal to 0. We have to factorize now. How to factorize? On multiplication we should get minus 8. On addition we should get plus 7. Okay, that is we are having minus symbol over here, so we have to subtract. On subtraction we should get 7. So we start. So possibility is straight away we are getting 1 into 8. 8 ones are 8. Okay, we take plus 8 minus 1. And now we are having 2 in the front. So we divide by 2. So it is x minus 1 by 2 into x plus 4 is equal to 0, which implies x is equal to 1 by 2, x is equal to minus 4. So we take only x is equal to minus 4, which is the integral value. X is equal to 1 by 2 is omitted. Why it is omitted? Because we are going to concentrate only on the integral value of x. We are going to concentrate only on the integral value of x. So this is how we have to use the idea of finding the transpose of a matrix. In this session, we used to calculate transpose of a matrix. Okay, and we did some problems based on the properties of the matrices. Okay, thank you, students.